Okay, you should be able now to see my screen, and I will also ask Remy, if possible, to unmute himself and provide the information.
Yes, so we have 3 questions so far. We have one question for Jelle. So on your presentation, on what is based the aging strategy? I think it refers to the protocol. Is there a standard? Shouldn't also the variation of pressure be taken into account? Jelle? Can you unmute yourself?
Hello?
Yes.
Can you hear me?
Yes.
Okay. So the aging strategy is based on the ETAC protocol, because I was collaborating with Redco, which is a company working in cladding systems, and they're familiar with this protocol. They also have the equipment to do these tests. But of course, I agree that there are other aging protocols or aging strategies possible, but this is the one we have chosen for. Second question, yeah, this is a standard. And the third question, should also the variation of pressure be taken into account? That was not explicitly taken into account, but I can mention that the pressures which we have to or had to use to measure the air permeability were actually high, up to 500 or 700 Pascal. We had to go to reach that level because otherwise we couldn't, because these samples were so airtight, otherwise we couldn't measure the airflow. The airflow was very low, so we had to go to high pressures. But this is not really explicitly mentioned in the test results.
Yes, but I think also the question refers to the fact that when you have pressure variations, you may have also accelerated aging because the stress on the tape is different.
Yeah, that was not taken into account. We didn't do any pulsation of pressures here in this investigation.
Thank you. And then we have another question for Xavier. In respect to defining a level of ambition, does it make sense from now on to plan for near-zero energy buildings as minimum? If yes, does this imply a minimum level of airtightness as well?
So in Belgium, you can hear me, okay? So in Belgium, the definition of the nearly zero energy building are more or less ready. So we know now what will be the minimal energy performance requirement. So, but it's a requirement at the level of the energy performance, and of course the airtightness has an impact on the energy performance. There is not really a direct link between the airtightness and the energy performance. But what we know is that you will have to have a very good airtightness performance. So it's evident that for nearly zero energy building you will have to have a very good airtightness performance. You could say about an N50 of maybe 1 or 2, maybe less. But actually it's depending on every building. So at every building level they can making their own calculation and define their own ambition level. In the reference document I show, if you follow all the steps I described, you really easily reach a level of certainly 3, and if you take some attention, certainly level of 1, which is compatible with the definition of DNZ.
Okay, thank you. Yes, I think also the question referred to the requirements in Belgium, which, as I understood, there's no minimum requirement in Belgium as for now. There's only a default value, and in most European countries, I think it's the same way, except for a few countries like France and the UK, I believe. Am I correct, Xavier?
Yes, it's indeed the situation, yes.
And then we have a last question. Is there possibly a trade-off between airtightness and long-term maintenance? So that refers also to the access of the airtightness barrier. I think this concerns both of you actually, with regard to durability and also with regard to the design of the airtightness.
So maybe I can give some element on this. We had other research projects very similar with those presented by Jelle, where we have some. Well, it was possible to make tests to see which elements are important regarding the durability of airtightness, and based on that we had some guidance how to design the airtightness barrier, for instance in light construction, to deal with the effect of the wind, for instance. It's not only the choice of the products, but it also has to do with the mechanical, the way you have installing the air barrier, and if you have some mechanical reinforcement of the air barrier. In many situations, the air barrier is not accessible anymore, certainly in light construction. For some construction details, for instance, the installation of windows, there are some details where you really installing joints that are still accessible when they are installed, and in this case maintenance is possible. There are other solutions with some system where you installing plaster in front of that, the air barrier is not accessible anymore. So you really have to take this into account for every solution. But we think in Belgium at least there are now some guidance available to design airtightness that will be where the performance will be sustainable with the time.
Okay, thank you. Alexander, do we have time for another question? I see that another one has shown up.
Yes, of course. Sorry, I didn't notice it. I will copy it directly.
Yes, is it possible to predict the airtightness level of a building during design phase? Are there methods? Then we have another one again. What is the NZ energy target in kilowatt hours per meter square for new houses, new offices, and the emission retrofit for each of these in Belgium? So the second question, I think, Xavier, you can answer too.
Yeah, my choice was for the first one.
Oh well, maybe for both of them if you can.
Yeah, the second one. Yeah, you know, Belgium is quite complicated country with 3 regions. So if we are starting discussing that, I think we will go much too far for this webinar. But maybe about prediction of airtightness. We had and since a lot of since many years now we had some experience with that, and what is that really prediction of the airtightness it's not working very good. What is possible if you really try to make an addition of all leakage is that in general it's an underestimation. But actually, the quality of realization of details is so important that really predicting the airtightness, on itself, it's not evident. What you can do, it's really, if I gave you the example of the boiler, you know, if you install this boiler, you really have to install there 2 openings, and you know the size of the opening if you choose for this the boiler. In this case, you precisely know what is the leakage corresponding to the installation of this boiler. So for this kind of element, it's obvious. But in general, for the overall performance of the building, it's not possible to predict what will be the airtightness. It's too much depending on the quality of realization.
Okay, Okay, thank you very much. So I think we should move on maybe to the following presentations, unless we have additional questions that have shown up. Alexander?
No further questions as far as I can see, but unfortunately, Katherine Sauvet has still not joined. She would be joining from another venue today. So we will have another small shift in the program. Filip will be the next presenter, and if in the meantime Katherine joins, she will be the fourth in order. So I make Filip the presenter now. Give him the floor for the continuation.